All right, so get this. We're diving into a real-life space drama today. You sent us a bunch of articles about Asteroid 2024 YR4, and honestly, it does feel kind of like something out of a movie.
It really does, right?
So let's break down what we know and figure out if this thing is really a cause for concern.
Yeah, it is interesting how often we get caught up in that, like, Hollywood version of these events.
Right.
But you know what's fascinating to me is that we're at a point scientifically now where we're not just passively watching these space rocks.
Right.
We're actively tracking them and even figuring out ways to potentially change their course.
Exactly. Okay, so first things first. What is 2024 YR4? Give us the lowdown.
Yeah, so let's start with just the basics. This asteroid was just discovered in December 2024 by the ATL system in Chile.
Okay.
And that system is essentially a network of telescopes that are constantly scanning the night sky, looking for anything that moves in a way that suggests it could be an asteroid.
So it's like our early warning system for space rocks, keeping an eye out for anything suspicious. Pretty cool.
It is, yeah, and based on how bright 2024 YR4 is and how it moves, astronomers estimate it's somewhere between 40 and 100 meters wide.
Wow.
So to give you a sense of scale, that's about the size of a football field.
Okay, not exactly tiny.
No.
Now I know everyone's wondering about the chances of this thing actually hitting us. What are the scientists saying?
Yeah, so the initial estimates had the probability of impact at around 1.2%.
Okay.
But as of February 19th, 2025, NASA has revised that number up to 3.1%, and the ESA has it at 2.8%.
Okay.
Now, these are all based on their latest observations and calculations, and it's important to understand that those numbers will likely continue to be refined as we gather more data.
A 3.1% chance. I have to admit, that sounds a bit unnerving.
Right.
And that's the highest probability we've ever seen for a potential asteroid impact, right?
That's true. It is the highest recorded probability, but it's really important to keep in mind that it still means there's a greater than 96% chance that it will miss us entirely. And I think what's intriguing here isn't just the specific percentage, but how scientists arrive at those numbers.
So break it down for us. How are they actually tracking this asteroid and figuring out its path?
So imagine you're trying to predict where a baseball is going to land after it's been thrown. You need to consider things like its speed, its direction, and any external forces acting on it, like wind resistance.
Right.
Tracking an asteroid is similar, but on a much larger scale and with much greater complexity.
Sure.
Astronomers are using telescopes and radar observations to pinpoint the asteroid's position and its velocity, and then they use sophisticated computer models to kind of project that trajectory forward in time.
Okay, I'm starting to get the picture. So
Yeah.
the more observations they get, the more accurate their predictions become.
Precisely. And it's not just about the quantity of the observations, but the quality as well.
Right.
And that's why there's been so much excitement about using the James Webb Space Telescope to observe 2024 YR4.
Oh.
Webb's incredibly powerful optics will give us an even clearer view of this asteroid, and that's going to further refine our understanding of its path.
Right. I remember reading that Webb can see things in space that no other telescope can. That's pretty incredible.
It is. It's like going from using a magnifying glass to using a high-powered microscope.
Right.
The level of detail we can get with Webb is just phenomenal.
Yeah.
But even with all this incredible technology, there are still challenges, right?
Yeah, what about the fact that 2024 YR4 will be hidden behind the sun for a while? I read that it'll be out of our sight from April 2025 until 2028. Doesn't that make things tricky?
It does. It adds a layer of complexities, like trying to track that baseball while it's passing behind a tree.
Oh.
We can't directly observe it during that time. So these observations we're making now are absolutely crucial.
Got it.
Scientists are trying to gather as much data as possible before we essentially lose sight of it.
Okay, so we've got a handle on how they're tracking it. But what if, hypothetically, it turns out that 2024 YR4 is headed straight for us? What are we talking about in terms of potential damage?
All right, so let's be clear. 2024 YR4 is not a planet killer.
Okay.
It's not going to cause a mass extinction event like the asteroid that wiped out the dinosaurs.
Right.
But if it did hit Earth, it could still cause some serious damage. Imagine an explosion equivalent to about 7.7 megatons of TNT.
That's a pretty hard thing to even imagine, 7.7 megatons of TNT. Is there anything we can compare that to?
Yeah, think about the Tunguska event back in 1908. That was a massive explosion in Siberia, most likely caused by a meteoroid or a comet fragment entering the atmosphere, and it flattened over 80 million trees across a huge area of forest.
Wow, I remember seeing pictures of that, just utter devastation for miles.
Exactly. And the energy released in that event is estimated to be in the same range as what we might see with 2024 YR4.
Okay, so definitely not something to take lightly, but is there any way to know where on Earth it might hit? I mean, is the entire planet at risk here?
Well, scientists have mapped out what they call a risk corridor based on the asteroid's projected trajectory, and it stretches across a pretty significant portion of the globe. It goes from the eastern Pacific over parts of South America, across the Atlantic through parts of Africa and the Arabian Sea, and even into South Asia.
Wow, that's a huge swath of the planet.
It is.
So given the potential danger, what are the experts actually doing about this? Are we just sitting here hoping for the best?
Not at all. This brings us to the fascinating world of planetary defense.
Okay, now that sounds like a topic for our next segment.
Absolutely.
We'll be right back after a quick break to dive into the world of planetary defense and what steps are being taken to protect Earth from asteroids like 2024 YR4. Don't go anywhere.
And we're back, ready to explore the world of planetary defense. Before the break, we were talking about that risk corridor and the potential impact of 2024 YR4. It all sounds pretty intense, so how prepared are we to deal with a real asteroid threat? That's the question everyone's asking, and it's one with a multi-layered answer. I think, on one hand, we've become remarkably good at detecting and tracking these near-Earth objects.
Right.
Telescopes are constantly scanning the skies. We have incredibly sophisticated systems to analyze that data and calculate those asteroid trajectories.
So at least we've got our eyes on the skies, but let's say we do spot an asteroid on a collision course with Earth. What then is that DART mission, the one where they smashed a spacecraft into an asteroid? Is that really our best defense right now?
Yeah, DART was a monumental success in proving the concept of kinetic impact. We now know for sure that we can change an asteroid's trajectory,
right,
even if it's just a little nudge. But keep in mind, that was a test on a relatively small asteroid.
So scaling that up to deal with something like 2024 YR4, that's a whole different ballgame.
Exactly. If we were facing a real threat from a larger asteroid, we'd likely need a much more powerful impactor, or even a combination of different deflection techniques.
Okay.
It wouldn't be a one-size-fits-all solution.
So what other options are on the table? This is where it starts to feel like we're stepping into science fiction territory.
Well, there's been some really interesting research into using what's called a gravity tractor. Essentially, you'd use a spacecraft's own gravitational pull to, very slowly over time, nudge an asteroid off course.
Wow.
And then there's even talk about using concentrated solar energy. You could potentially vaporize a section of the asteroid's surface, creating a jet of gas that would act like a thruster.
Whoa, so we've got options, but it seems like no matter what method you're talking about, timing is everything.
You're absolutely right. The earlier we detect a potential threat, the more time we have to react to plan a strategy and potentially implement a deflection mission.
Which brings us back to that observation blackout with 2024 YR4 going behind the sun. That must be a huge factor in all this.
It is. It means we have a limited window to gather that crucial data and refine our understanding of its trajectory before it essentially goes dark for a few years. And that data is the foundation for any informed decisions about potential mitigation efforts.
Yeah, I'm starting to see why this whole situation is so captivating. We're not just talking about an asteroid out there. We're talking about cutting-edge science, international collaboration, and this real sense of urgency.
You've hit the nail on the head. This situation really highlights the delicate balance between monitoring potential threats and pushing the boundaries of our scientific knowledge. We have to be aware of the risks out there in our cosmic neighborhood.
Right.
But at the same time, we can't let that stop us from exploring and pushing the limits of what's possible.
So let's bring this back to 2024 YR4. What are the next steps here? What's happening right now?
Right now, the focus is on gathering as much data as possible before that asteroid becomes obscured by the sun.
Okay.
Scientists are using ground-based telescopes, space telescopes like the James Webb, and even radar observations to track its movements and get the most precise understanding of its orbit.
And then based on all that data, they can determine the real level of risk and decide if any action needs to be taken.
Exactly. And it's important to remember, even though that probability of impact is increased, it's still relatively low. The most likely outcome is that further observations will show 2024 YR4 will pass by Earth without any problems. But even if that risk remains elevated, we are not powerless. We have the knowledge, the technology, and just as importantly, the international cooperation to address this type of challenge.
That's reassuring to hear, but this whole conversation has made me wonder about the bigger picture, what other threats are out there, and how are we preparing for them? It feels like there's so much more to explore here.
You're right, this is just the tip of the iceberg, and that brings us to the amazing field of planetary defense as a whole.
Here's where it gets really interesting. We'll be right back to dive into the world of planetary defense, the science, the technology, and the global effort to protect our planet from those cosmic threats. Stay tuned.
And we're back for the final part of our deep dive. We've been talking about Asteroid 2024 YR4 and what we're doing to protect Earth from potential impacts. But before the break, we started to touch on this whole field of planetary defense. It's kind of mind-blowing to think that we're actually at a point where we can take steps to defend our planet from these cosmic threats. It really is a remarkable shift in our perspective. We've gone from seeing asteroids as these distant, mysterious objects to understanding them as dynamic entities that we can potentially interact with and even influence.
It makes you realize just how much our understanding of space has evolved over time. So when we talk about planetary defense, what exactly does that entail and who's calling the shots? Is it all NASA or the ESA?
Planetary defense is a truly global endeavor. It's a network of scientists, engineers, and policymakers from around the world who are all working together to protect our planet from asteroid impacts.
So it's not just one country or agency taking the lead.
Not at all. There are a number of international organizations that play key roles in this effort. One of the most important is the International Asteroid Warning Network, or IAWN for short.
Okay.
And they coordinate the efforts of observatories and space agencies around the world to detect and track potentially hazardous asteroids.
So it's like a global neighborhood watch for space rocks, making sure we're keeping tabs on anything that could pose a threat.
That's a great analogy. And then there's the Space Mission Planning Advisory Group, or SMPAG, which is endorsed by the United Nations. Their focus is on developing strategies for actually deflecting or mitigating the threat posed by an asteroid that's on a collision course with Earth.
Okay, so we've got IAWN watching the skies and SMPEG figuring out what to do if something comes too close for comfort. It sounds like a pretty solid team.
It is, and it's a team that's constantly evolving and improving. We're constantly learning more about asteroids, and we're constantly developing new technologies to track and potentially deflect the missions like DIRT are pushing the boundaries of what's possible in terms of planetary defense.
It really is like something out of a science fiction movie, but this is real life. It's both exciting and a little bit daunting to think about.
I agree, but I think it's ultimately a story of human ingenuity and collaboration. We're facing a cosmic challenge, and we're rising to meet it head-on using science and technology to protect our planet.
Okay, so let's wrap things up with some key takeaways for our listener. First of all, we know there's an asteroid out there called 2024 YR4, and there is a small chance it could hit Earth. But
it's absolutely crucial to keep in mind that the vast majority of asteroids, including 2024 YR4, will miss us completely. And even if an asteroid did pose a real threat, we're not helpless. We have incredibly dedicated scientists and engineers working around the clock to monitor the skies and develop those planetary defense strategies we've been talking about.
So basically, stay informed, but don't panic.
Exactly. This whole situation is a reminder that we live in a dynamic solar system, but it's also a testament to our ability to use science and technology to understand and even control our cosmic destiny.
I have to say, this whole conversation has really opened my eyes to a side of space exploration I hadn't really thought much about before, and it leaves me with one final thought-provoking question for our listener. We're pouring resources into monitoring potential threats like asteroids, which is obviously important, but how do we balance that with the ongoing exploration of the vastness of space? Is there a point where one becomes more important than the other? It's definitely something I'll be thinking about.
That's an excellent question, and one that sparks a crucial conversation about our priorities as a spacefaring species. Thanks for joining us on this deep dive.
And remember, while there might be asteroid out there, there's also human curiosity and our drive to understand and protect our planet. We'll see you on the next deep dive.